Hi everybody, let's talk about Unit 16 assembly drawings. The previous lecture was on Unit 15 detailed drawings, and detailed drawings work well with assembly drawings, and so we've combined them this week in order to catch you up. And Unit 16 is on page 323. There obviously is some learning objectives that I want you to review. Those are located on page 323, and there's also the technical terms like every other unit. So make sure you go through those technical terms, make sure you're comfortable with those, and you should be good to go. So let's talk about assembly drawings. Assembly drawings, basically very rarely are you going to have the opportunity to work with a single part. And so most of what you're going to do in your career is work with machines, work with assemblies. And assemblies are just basically a bunch of parts put together. Either they're welded together, they fit together with fasteners. And so an assembly drawing shows that working relationship of the various parts of a machine structure or product as they fit and function together. And with CAD systems now and animated software, it's even becoming where we can sit down in front of a CAD model and play it and actually see that animation. So it's very important that you understand the relationship between detailed drawings and assembly drawings. And go back and remember from Unit 15, we classify these as working drawings. Now in this textbook uses lots of different nomenclature when it comes around to assembly drawings. They kind of put this little statement in here for the scope of this text. Drawings, if inseparable assemblies such as welded parts or parts with inserts, are considered in the same context as detailed drawings. So what they're basically saying is that if you pick up a drawing and it's shown as two pieces welded together, most of the time somebody would call that a detailed drawing. Somebody may also call it a detailed assembly drawing, or somebody may call it an assembly drawing. And so just like lots of other things in our trade, it's important that your communication with someone is clear, is concise, and then that way everybody's on the same page. Assembly drawings. So what do they include? Well, they include the name of the assembly or the subassembly. They have a list of separate parts. We use Balloon's parts lists. I'll cover that off in a little bit. They show various size dimensions related to the assembly. I'll go through some of those rules. They have other information that cannot be determined from separate parts or from detailed drawings. And often you have sometimes pages, depending on the depth and the scope of a project or of a machine, general notes about that assembly. So here's a drawing, figure 16-1, that's located on page 325. And this is really an up-to-date drawing, shows a nice isometric view here. It shows our top view, our front view, and our side view. And then it has a lot of leader lines with balloons to identify the parts. So this is a typical assembly drawing that you're going to see. Sometimes they have virtually no dimensions. Assembly drawings are often multi-view drawings, as I've illustrated before in the previous slide. They may be sectioned in one or more views if absolutely necessary. They should only contain hidden lines, if you really need them. And what do I mean by that? Well, basically only include hidden lines to show how parts are assembled. Center lines are appropriate. Often we use center lines to dimension to or from something, down the center of a conveyor, through the center of a shaft. And so center lines you're going to find are used often in assembly drawings. Dimensions can be included if, and there's a couple rules around these aren't set in stone, but they're just good guidelines that only use dimensions if they show the overall measurements, so like a working envelope of that assembly or the overall footprint of that assembly. How big is that assembly going to be when it's finished, so that somebody knows the physical size how much room it's going to take up on a shop floor, for example. And dimensions can be included if there's a range of motion. So if we have handles that are moving, if we have something that has to swing, and so we have to make sure that we have enough area in where that machine is going. Those are some general guidelines around using dimensions in an assembly drawing. So here's another example of an assembly drawing. You're going to see this drawing in Practical 3200 when you're asked to produce this bench vise. And here again, you can see that this assembly has, we'll call this our front view, and we'll call this one our side view. And so in this assembly drawing has no pictorial view, has no isometric view, and really all this is doing is showing you how does this thing look when it's assembled. It has our leader lines with our balloons. They correspond to our parts list over here, which is on top of our title block. Further to assembly drawings, we can have sub-assembly drawings, and basically sub-assembly drawings just show a few parts assembled. Sometimes the assembly drawing can get very cluttered, and we need to pull out a sub-assembly area so that we can be sure that we're clear and concise when we're creating that drawing. Here you can see in this particular part that we have a pulley on the outside and we have a bushing on the inside, and there's a general note here about press fitting that bushing, do not damage the inner bushing hole. There's a lot going on in this sub-assembly, so the draftsperson or the engineer wanted to make sure that those notes are highlighted. You can see how that's assembled. You can see the part number for the pulley. You can see the part number for the bushing very clearly. And so this is a great example of when we would use a sub-assembly drawing. A detail assembly drawing basically goes one step even further. Here we have a couple of parts. We have a lot of detail now in this assembly drawing, and so we call this a detail assembly drawing because you have numerous dimensions on it. This is an all-encompassing drawing. It's not just one specific part. We've got both parts that obviously have to fit together and run together, and so the draftsperson, in this case the engineer, decided, okay, we're going to show it together and we're going to put all the dimensions, all the notes, everything that's required around these two parts. As I've noted in here on the slide, it's not really a recommended practice. A lot of times it can get very busy on a drawing when you try to do something like this. But in some cases, you're going to run across assembly drawings that really have that level of detail. And so the textbook calls these detailed assembly drawings. I think technically when you're out in the workforce, you're just going to refer to them as an assembly drawing. Another type of assembly drawing that the textbook talks about is one called a diagram assembly drawing. Here they show the parts to be assembled basically as symbols. This is on page 327 in your textbook. So, they're using symbols joined with single lines to kind of show a piping flow. So you're familiar with this with pneumatics and hydraulics. You can have this as well with a wiring assembly, so electrical schematics. It's basically explaining to you, the end user, how to assemble parts, and so therefore symbols are shown, not usually any dimensions, lots of general notes, and these fall under the title of diagram assembly drawings. Here's what I call the, IKEA exploded assembly drawing. I think if any of you have put together any furniture that you've bought from IKEA, or components of a TV stand, anything like this, this is the standard exploded assembly drawing, and where we take an assembly and we literally pull it all apart, and we use phantom lines to show how our fasteners go together. Extremely cluttered, tough sometimes to interpret. It takes a little bit of time to kind of get familiar with this and utilize it and be able to accurately work with this type of drawing. But it is the type that you see more and more. CAD systems can create these very easily, and so it doesn't take long for a draftsperson to create an exploded assembly drawing. We talked earlier about identifying parts in an assembly drawing, and that an assembly drawing contains balloons and the parts list. And so this is a perfect example in your textbook of an assembly drawing showing that I have lots of balloons, lots of leader lines. I have my parts list over here. This is actually an exploded assembly drawing, because you can see now we've pulled these parts out. We're showing that this goes through this part and then in through here with this phantom line. So it's showing the details as individual parts and how they would fit together in that assembly. A really good example of an exploded assembly drawing with lots of part identification. We talked earlier about sections in the assembly drawing. Sometimes we have to use them, especially when we have lots of parts touching one another. I think one of the big things you want to make sure you keep in mind with sections in an assembly drawing is that your section lines are turned at different angles. The scale of them and the spacing should be different. A great example of this is if we look into here, we can see the spacing is very small. Here we have a different angle. And so we just want to be clear, we want to be concise, and we want to make sure that there's no misinterpretation when we use sections in an assembly drawing. Sometimes you're going to have multiple assembly drawings, and so then we get an application block. That application block is usually found on the left-hand side of the title block, and we talked about these before, but basically on the left, it's going to tell you the next assembly and then where it's used on. So 5497 would be an assembly, 5487 would be an assembly, and then certain assembly drawings are going to be used on those assemblies. Couple slides previous, over here, I talked about the parts list. And so, just to define more about the parts list, basically, this is a dead giveaway that you're working with an assembly drawing when you see a parts list on top of the title block. A basic parts list should include a find number. I like to call this a detail number or a part number. This textbook likes to call it a find number, but means the same. We have the quantity required. We have part numbers. And then we have part names. And so usually you'll see this block being referred to as a parts description or just simply the description. There's some additional things that go on in a parts list. We could have cage codes. Cage coding is shown here with the balloon A. And, cage codes appear on an assembly drawing when the part is kind of, applicable to a federal government type part, something of very official, and that you have to use that specific part. The acronym CAGE actually stands for Commercial and Government Entity. Be aware that there's lots of times in a parts list where you will have a specific procurement specification or a vendor who you have to use in order to get that part. And again, if you're working in something that has, very specific rules, very specific structure, procedures, be aware of that in the parts list. Also, additional things may be material, weight, notes or remarks, and then obviously our drawing zone location. That goes way back to the beginning when I first met you, having the assembly drawings on very large pieces of paper, D size, E size, even bigger. We have to sometimes refer to the drawing zone location to help someone find where that part is. And lastly, assemblies can have different versions. And so when you have more than one version of an assembly, each version is identified by a dash number following the assembly number. So if you have multiple assemblies, you're going to run into an example like this where you would have your assembly number 65302-1, and you would have that same assembly but a different version, so 65302-2. Pretty simple stuff. That's on page 331. And page 332 gives an example as well in figure 16-11. What do we do this week? So we've already had Unit 15 and the quiz that goes with Unit 15. I need you to do quiz number 6 as well. That uses Industry Print 16-2. Industry Print 16-2 is found on page 337. There's also some review questions on page 333, and I will upload the solutions for those into DC Connect. And so that concludes all of the lectures for Blue 2401. I want to thank you for your excellent effort and continue to stay healthy. Cheers.